Every black hole hides something we can never see. Not light. Not matter. Not even time. At the edge of a black hole, space bends so violently that the future and the past lose their meaning. The laws of physics, the same laws that explain stars, planets, and even atoms, simply stop giving answers. And that leads to a disturbing question. What exactly lies beyond a black hole? Is it destruction, or is it transition? Some equations suggest that a black hole may not be an endpoint at all, but a boundary. A boundary between this universe and something else. Another universe. Another reality. Is this science, or is it science fiction? And more importantly, why do serious physicists even consider this idea? In this video, we explore one of the most profound and controversial questions in modern cosmology. Are black holes portal to another universe? A black hole is not a hole in space, and it is not a tunnel you fall through. A black hole is a region where gravity becomes so strong that space and time themselves are infinitely curved. The boundary of this region is called the event horizon. Once anything crosses it, light, matter, or information, it can never return. This is not because something blocks the way out, but because space itself is falling inward faster than light can escape. Inside this region, our equations still exist, but our ability to interpret reality fails. At the center of a black hole lies what we call a singularity, a point of infinite density and infinite curvature. General relativity predicts this singularity with precision, but quantum mechanics cannot explain it. This conflict is critical. It tells us that black holes are not just extreme objects. They are boundaries where our understanding of physics breaks down. And whenever science reaches such a boundary, radical possibilities appear. This is where the idea of portals enters the discussion. Einstein's equations, the same equations that predict black holes, also allow mathematical structures called Einstein-Rosen bridges, more commonly known as wormholes. These are theoretical connections between two distant regions of space, two different moments in time, or even two different universes. In theory, a black hole could form one end of such a bridge. However, these wormholes are unstable. They collapse instantly. With all known physics, nothing can pass through them. So while mathematics allows the idea of a connection, physics does not allow the journey. This means black holes are not usable portals. Then there is an even stranger concept, white holes. A white hole is the exact time reverse of a black hole. Nothing can enter it, matter and energy can only exit. White holes are allowed by equations, but none have ever been observed. Some speculative theories suggest that a black hole in our universe could appear as a white hole in another universe. In this view, black holes do not destroy information but transform it. However, this idea exists only on paper, not in observation. This leads to one of the boldest ideas in cosmology. What if our entire universe was born inside a black hole? Some models suggest that every black hole could give rise to a new universe, with its own space, time, and physical laws. Such a universe would be completely disconnected from the parent universe. This does not mean travel between universes is possible. It means black holes could be cosmic generators rather than gateways. There is no experimental evidence for this idea, but mathematically, it remains consistent, and that alone keeps it alive in scientific debate. Black holes are not doors we can open. They are limits, places where reality itself reaches an edge. And beyond that edge, science has not yet gone. Black holes remind us of something profound. The universe is under no obligation to be simple, only consistent.